An intercooler is a vessel that is employed in two-stage systems. It operates at an intermediate pressure between the high and low sides of the system. The intercooler maintains a level of intermediate pressure liquid that the booster discharge gas percolates through. This desuperheats the booster discharge gas so that the vapor exiting the top of the intercooler, while at the same pressure, has a lower temperature. Liquid is supplied to the intercooler from the high-pressure receiver through an expansion device. The flash gas that forms is separated inside the intercooler and is piped directly back to the high-stage compressor and never passes through the evaporator. Liquid from the intercooler is piped to a second expansion device where the temperature and pressure is further lowered as it enters the evaporator. Due to ammonia's high theoretical discharge temperature, two-stage systems and therefore intercoolers are essential when there is a large differential between evaporator and condensing temperatures. Utilizing an intercooler and two stages of compression allows the system to operate more efficiently and with lower discharge gas temperatures. The downside, however, is the increased system cost and complexity.
I've depicted here a setup for a simple two-stage refrigeration system so that we can talk about an intercooler, all right? And the type of intercooler I brought up here is often referred to as a flash intercooler. It's the most common type of intercooler. And this is the unique vessel that's utilized in two-stage systems. So why do we go with two-stage systems? Usually, the reason two-stage systems are employed is because we want a very low temperature in our evaporator, a freezer-type facility. And if we try to do that in a single stage, our theoretical discharge temperatures are going to be far too high. It's going to cause all sorts of problems with the system, break down our oil, and you just can't do it. So we're going to go with a two-stage system, and that introduces a little bit of complexity. So let's talk about what an intercooler does. An intercooler is a vessel that operates at an intermediate pressure that's between the high pressure side, that's the red depicted here, and our desired low pressure. That's the green here. So the blue an intercooler is an intermediate pressure that's roughly halfway between those two pressures. So the intercooler is receiving liquid from a high pressure receiver through an expansion valve, kind of the same way an evaporator does. And it's got a flow or some kind of level control so that it maintains a level of this intermediate pressure liquid. Okay, so that's function one, is maintain this level. Now, why do we want this level? Well, in this example, so we have liquid to supply to our evaporator. Now, we're going through a second expansion device. So we're going to lower the temperature and pressure of that liquid another time. That's the transition our blue color, or intermediate pressure temperature liquid, into our desired low temperature pressure liquid that enters our evaporator. Inside the evaporator, we know what happens. It absorbs heat, liquid evaporates, is returned to a compressor that we call a booster compressor. Sometimes in kind of textbook type of language, it might be called a first stage compressor, but more often than not, it's a booster compressor, the OU label. And the discharge from that booster compressor is at the intermediate pressure, the same pressure as at the intercooler. So it is superheated vapor, but it's not at the same temperature or pressure as our high stage compressor. So this discharge, instead of going to a condenser, goes into our intercooler, and I draw it here so that the pipe enters the vessel and kind of goes to the bottom. And we know this vessel that I told you is filled with liquid. So vapor, superheated vapor, exits this pipe at the bottom, and then is allowed to percolate and bubble through that liquid bath that's maintained in that vessel. And in that process, that superheated vapor gets de-superheated. And that is one of the other main functions of the intercooler, which is to de-superheat the booster discharge gas, because that's what we need to do. We need to lower our overall discharge temperature. Now the vapor that is supplied from our intercooler to our high stage compressor is already de-superheated. It's at a lower temperature, but the same pressure. And that's one of the things we're trying to accomplish. Now I have that depicted here. There is a condenser. The high stage compressor sends vapor to the condenser, is returned to the receiver, and that will conclude our cycle. But so that gives you the overview of intercooler.